Hello Algebra 2 people. So here's a video of your first practice exam, and I've broken it up into 4 pages, so feel free to go to the part you most want to see. So I'm going to start with number 1 here. Notice that you have a fraction as a lead coefficient. So I know you guys are not fond of fractions, so the first thing I'm going to do is just get rid of the fraction. So if I multiply everything by 2, I get x squared minus 4x equals 12. Make sure you go all the way through. And now it's a much friendlier looking problem. So we know we're going to set it equal to 0. And then you're going to do your little diamond method to see what times what. So a times c is a negative 12. And this is your negative 4. So what times what is negative 12 but adds up to a negative 4? That's negative 6 plus 2. And so now, because you have a 1 in front of your x squared term, you're allowed to just use those numbers. So this is your factored form of the quadratic, and then you set each factor equal to 0. So this becomes x plus 2 equals 0. So we know that x equals 6 and x equals a negative 2. So x equals 6 and negative 2. Okay. On number 2, notice we only have the 1 squared term. So what we're going to do is the square root method, which means you want to isolate x squared before you do anything else. So the first thing I'm going to do is subtract 8 from both sides. So that gives me 4x squared equals a negative 24. I still have to isolate my x squared, so I divide through by 4, and I get x squared equals negative 6. So now you are ready to take the square root of both sides. Remember, you have to do the plus or minus because you expect 2 answers. And so on this side we have x plus or minus. So this is the same thing as square root of negative 1 times the square root of 6. So the square root of negative 1 comes out as I, and then we still have the square root of 6. So x equals plus or minus, because you have 2 answers, I square root of 6, which we cannot simplify. You do need to simplify your radicals. Okay, on number 3, so we have the 2 terms with an x, so we're going to have to try and factor this. So we want to set it equal to 0, so minus 5x from both sides. And then we do our little diamond method. So a times c goes on top, so that's a negative 6. Down below is your b term, negative 5. And let me see, if we had a negative 6 plus 1, that would give me a negative 5, but multiplied to a negative 6. Now, those are not the terms that go into your parentheses because you have the 2 in front. These, however, do add up to negative 5, so we use them to break up negative 5. So we rewrite this as 2x squared minus 6x plus 1x minus 3. And now what we're going to do is called factor by grouping. We're going to look at these first 2 terms, and then we're going to look at the next 2 terms. So what's common to the first 2 terms is 2x, and we pull out x minus 3. What's common to the next 2 terms is nothing, but that really is a 1, and you want to have that placeholder of 1, so you still have x minus 3. And again, you know you did it right if these 2 terms are exactly the same. So now we have 2 terms here. We have this term and we have this term, and they both have x minus 3 in common. So I factor out the x minus 3, and what's left, the 2x and the plus 1, get left behind. And so that is the factored form. We still have to solve this. So you're going to set x minus 3 equal to 0, and you're going to set 2x plus 1 equal to 0. So we have 2x equals a negative 1. So x is going to be a negative 1/2, and on this side, x equals 3. You will always have a fraction on these ones. So x equals 3 and a negative 1/2. Okay, on number 4, you have a nice friendly, it's already set equal to 0. We can go straight to the diamond, so negative 24 times 1, and then a negative 5. So that is going to be, let's see, negative 8 plus 3 will give you a negative 5. And since it's a 1 in front, that is what goes into our parentheses. X plus 3 equals 0, and then you just set each factor equal to 0. So x equals 8, x plus 3 equals 0, so x equals a negative 3. So x equals 8 and negative 3. All right, so that's the factoring part of your practice exam. Now for completing the square, remember it's a 5-step process. So step number 1 is you want to isolate the squared and the x term. Whoops, I wrote it wrong. So let me go back and, oh, fudge. Let's see. We want to just do that. Okay. So x squared minus 10x plus blank is going to equal, so we're adding 7 to both sides, so we have a 7 plus blank. So we're adding something to both sides, and then we are going to take half of the middle term and square it. That's what gets added to both sides. So 5 squared is getting added to both sides. Now you are ready to complete the square on this. So it will always be a perfect square. You made it that way. So it's always going to be x minus, this is always going to be x minus or x plus, whatever your b over 2 is. So in this case our b is negative, so minus 5, 10 over 2. And then, and again, check. So 5 squared is 25, negative 5 plus negative 5 is a negative 10. So we know that that's going to work. And then we have 7 plus 25, which is 32. So now we're ready to do the square root method. So the square root method is when you take the square root, and there's a plus or minus, because we need 2 answers of both sides, and we start to simplify. So we know x minus 5 is going to equal plus or minus, and we have to simplify this. So 32 is 16 times 2, which simplifies to 4 rad 2. And our last step is to isolate x. So we add 5 to both sides. So we have 5 plus or minus 4 rad 2. X equals plus or minus 4 rad 2. So that's what factoring and completing the square will look like. On this page, we're going to do the quadratic formula, and you want to make sure you know how to simplify your radicals, okay? So, just like before, we want to make sure we set everything equal to 0, so plus x minus 3 equals 0. I recommend you identify your a, b, and your c. So we know a is a negative 2, b is a positive 1, c is a negative 3. So we're going to do the discriminant first. So b squared minus 4ac, there's no radical involved. So that's going to be 1 minus 4 times negative 2 times a negative 3. Since I have a total of 3 negatives going on, I know that's going to stay negative. An odd number of negatives keeps you negative. So it's going to be 1 minus 4 times 2 is 8. 8 times 3 is 24. So this is going to give me a negative 23, 1 minus 24. So my discriminant is negative 23. That means, because it's a negative number and it's going to go under a radical, that I have 2 imaginary roots. So now we actually want to do the quadratic formula. So x equals the opposite of b, negative 1, plus or minus the square root of negative 23, all over 2 times a, and we want to simplify what we can. So x equals negative 1 plus or minus, the negative under the radical comes out as I, and fortunately 23 can't be simplified, and then on the bottom we have a negative 4. And that's really all you can do with that one. So negative 1 plus or minus I rad 23 all over a negative 4. Put the I always in front of your square root so it doesn't look like it's still underneath. Okay, so let's try this again. So we want to put this in standard form. I like to have my squared term positive, so I'm going to keep 3x squared here and add 12x to both sides plus 1. So we added 12x to both sides. So we have a is going to be 3, b is going to be a positive 12, and c is going to equal 1. So doing the discriminant first, b squared minus 4ac gives me 144 minus 4 times 3 times 1. So 144 minus 12 is going to be 132. Okay, so that means my discriminant is actually just 132, and that's a nice positive number. So that means I have 2 real roots. And now we do the quadratic formula. X equals the opposite of b plus or minus radical 132 all over 2 times a. Okay, so off to the side, let's simplify this 132. So 4 goes into 32, so it probably goes into this. So let's see, 4 times what would be 132 turns out 4 times 33, if you use your calculator to divide. So this will simplify to 2 rad 33. So I have negative 12 plus or minus 2 rad 33 all over 6. And at this point, I want to break it up. So I have negative 12 over 6 plus or minus 2 rad 33 over 6, and I can then simplify each fraction individually. So negative 12 over 6 is 2 plus or minus, so the 2 and the 6, this becomes rad 33 over 3, and that would be your final answer. So we have 2 plus or minus square root of 33 over 3. All right, so make sure you take your time and simplify step by step. A lot of people kind of make a mistake at this point. They don't simplify in front of the radical correctly. Okay, last problem. Now these 3 were meant to be sort of give me problems, so I'm hoping they were easy for you. The main thing, and I will try and make sure you have really clear graphs, here is your x-axis. This is the x-axis in each one of these problems. So to find the actual solutions, what you're really doing is finding the x-intercepts. Because remember, solutions, roots, x-intercepts, it all means the same thing. So when I read this off, I'm just reading where this crosses. So x equals 0 and negative 4. If it doesn't cross, that means you have no solution. You have imaginary roots, but we don't know what those are. Here you only cross once because you actually have a perfect square. So you do not have to write it twice, you just have to write that that's going to be at negative 2. Okay, now we're getting into working with our complex numbers. So just be really careful when you're reading these. So if you see a minus or a plus in between, that means you're just combining like terms. So what I'm really doing is I'm going 4 minus 6, those are the real part. And then I'm going to add that to 12i minus a negative 8i. So the real part is going to be a negative 2, and the imaginary part, since these are the like terms, will be 20i. And so that's your answer, negative 2 plus 20i. Now if you see nothing in between but the 2 parentheses are butted together, you have to FOIL. So you want to make sure you do this carefully. So 7 times 3 is 21. 7 times a negative 6i is negative 42i. And then we do our inner. So that's going to be 4i times 3, which is 12i. And our last terms, 4 times 6 is or negative 6 is a negative 24i squared. Now, a lot of people on the little mini quiz got this one wrong, because remember that I squared equals a negative 1. So what it does is it changes the sign of whatever comes in front. So what I really have here, when we go through and simplify, we have 2 like terms here, So I have 21, negative 42 plus 12 is a minus 30i, and then I have plus 24 because I squared turned into a negative 1. So I can still combine my first and last term, so that's going to be 45 minus 30i, and that would be your final answer. Okay, so make sure it's not considered correct if you leave your I squared in there. So on these last ones, I think most of you have it, except sometimes you lose your negatives. So we're going to so here, remember, is what a complex number looks like. So you're setting the real part equal to the real part. So we have negative 3x equals 9. So x equals a negative 3. And on the other side, the imaginary part. So you have 4, we don't need the I, equals 2y. And so dividing by 2, y is going to equal 2. So you have an answer of x equals a negative 3 and y equals 2. All right, so that's your complex part. And now we get into the word problems. All right, so we have a rectangle. So the rectangle has an area of 250, and we know area is base times height or length times width. So the length is 5 more than twice the width. So 5 more than twice the width, and the width then would be w. Okay, so we're going to go through. Oh my goodness, I was just looking at my answer online and it's wrong. So we're going to correct that. All right, so we're going to go through and multiply this. We know that area equals w times 5 plus 2w, and that's going to equal 250. So we're going to distribute. So that's going to give me 5w plus 2w squared equals 250. And then we're going to set this all equal to 0 so that we can solve it. So we have 2w squared plus 5w minus 250 equals 0. Now, unfortunately, you can't divide everything by 5 because you have a 2 in front here. So this is one of those where we're going to end up doing factor by grouping. But realize, in the end, we are expecting to have 2w times w in factored form, because that's the only way I'll get a 2w squared. So let's take a look at some of our options here. We have, actually I did that wrong, because that should be a times c. So that's going to be negative 500, and down here is going to be 5. Okay, so you have to figure out what times what is 500 and goes into 5. So what I usually do is I sort of create a little factor tree and I look at factors. So this is, 10 times 50, that's not going to give me 5. This would be 25 times 2. And I notice that 20 times 25 differ by 5. So this will be 25 and this will be 20. Except that this will be a negative. 25 minus 20 is 5. All right, so when we break this up, I'm going to have 2w squared minus 20w plus 25w minus my 250. So we're doing factor by grouping like we did on the front side. Pull out a 2w from each term. So that leaves me with a w minus 10, plus, on this one, I'm going to pull out a 25 from both of them, which leaves me with w minus 10. Voila, we have the same w. So I know that I can now fill in over here. So 2w plus 25 goes here, w minus 10 goes here. This one, when I solve, will give me a negative number. This one, when I set it equal to 0, will give me a positive 10. So my width is going to be 10, but the question asks for the length, which is 5 plus 2w. So 5 plus 2 times 10 is going to be 25. Okay, the last two, mathematical modeling. Now these you definitely want to have your calculator, and you are allowed to have decimal answers. These are the only ones I will accept decimal answers on. So it gives you the height of the basketball in feet, and then t represents seconds after it's thrown. So remember, -16 is gravity, so 32 would represent the initial velocity, and this would be from a height of 2, and it wants the maximum height of the basketball. So you throw a basketball and the path would look something like this, and the maximum height occurs at the y value of your vertex. So this is -b over 2a, and then you have to plug it in to solve for y. So the maximum height, the t value, is going to happen at -32 over 2 times -16. So it happens in 1 second. So what is the height at 1 second? It's -16 times 1 squared plus 32 times 1 plus 2. So -16 plus 32 is 16 plus 2. So that's going to happen at 18 feet. So not time, but feet is what you want for the maximum height. Now it says the basketball is caught in its descent when it is 7 feet. So if this was at 2 feet, it was caught up here at 7 feet above the ground. How long is the basketball in the air? So how long, we're trying to solve for time. So we're setting our equation equal to 7. So -7 equals, or 7 equals -16 t squared plus 32t plus 2, and then we set that equal to 0. So -16 t squared plus 32t. Since we are subtracting 7 from both sides, this will be a -5. So you're going to do your quadratic formula. So again, I always recommend you do your b squared minus 4ac first. So in this case, that is going to be 32 squared, which is 1024, minus 4 times -16 times a -5. Notice I have 3 negatives, so everything's going to stay negative. So 1024 minus 320 is going to equal 704. So we're going to go x equals the opposite of b, which is a -32, plus rad 704 over 2 times -16. But we also have -32 minus, so I'm breaking up your plus or minus into 2 equations, because you have to figure out which one is going to give you, and actually I apologize for that, I should be putting in here t's for time, because that's what we're actually solving for. Our x is time. So when you solve for that, you get 2 answers. One of them is going to give you 0.17, and one of them is going to give you 1.83 when you solve these out. So one will give you 0.17, one is going to give you 1.83. So when you look at the path of the ball, it's at 7 feet twice. So 7 feet here, 7 feet here. You want the larger number because you want when the ball is coming down. So you want to give 1.83 for your answer. Okay. Now it's going to be up to you to come up with the equation, but notice in the previous problem I gave you sort of the structure there if you understand where things came from. So in general, you have the height is going to equal the -16, that will always be there, that's your gravitational constant, plus v naught t, that's your initial velocity, plus your initial height. So the juggler tosses a ball in the air and it leaves the juggler's hand at 4 feet, that is going to be your initial height, with an initial velocity of 30 feet. Since it's going up, that's going to be a positive 30. So your equation is going to look like this, -16t squared plus 30t plus 4, the initial height. All right, and it wants to know how long is the ball in the air, which in other words, we're trying to find out when, at what time does the ball hit the ground again. Okay, so you're just setting that equation equal to 0 and solving by quadratic formula. So we're going to do like we did before. We're going to do our b squared minus 4ac, which is going to give us 900 minus 4 times 4 times a negative 16, 4 times a times c, and so that's going to give me 900. So that's going to give you 900 plus 256, which equals 1156. All right, so now let's do our quadratic formula. So we have x equals negative 30 plus, and then negative 30 minus the square root of 1156 all over 2 times a, which is a negative 32. Now the nice thing about this problem is it turns out that 1156, the square root of that is actually, it's a perfect square, it's 34. So we are going to have negative 30 plus 34 divided by negative 32, and negative 30 minus 34 over negative 32. So 34 minus 30 is 4 over a negative 32. This one's going to give you a negative answer. 4 over negative 32, that's going to give you a negative 1/8. So time, again, this should be time, cannot be negative. The top one gives you negative 64, or this bottom one, negative 64 over negative 32. That is comes out to be a nice positive. Time will equal 2 seconds. Okay, so these are not easy problems. You have to take your time, and you want to do them step by step, and you definitely want to be able to use your calculator. Okay?